Welcome again to the Electricity and Magnetism Laboratory. My name is Dan Ludwigson, and in this week's lab, we are getting into some important measurements, notably of voltage. This will be the first time we're measuring voltage. We have a multimeter. These guys are, you're going to turn them on with the yellow button. A couple of things to mention. We want to make sure that we're measuring volts, and we're plugged into the port that's labeled volts. The other port is the common ground port, so that's going to be our reference location. I've attached that to the ground of the power supply, just to make sure that we're all referenced. To turn on the power supply, power switch is down there, and we've got a voltage and a current setting here. And we can switch between the two with this button underneath the knob. So if the voltage number is flashing, I can change that. We're going to set it to 10 volts for this week's lab. And we press it again and we can adjust the current. We're not going to need to limit the current this week, I hope, but that will allow you to set a maximum. I put that at 0.5 amps. We definitely won't get 0.5 amps running through today. All right, another push and it goes back to kind of the default state. To get this to be active now, we want to push the button that says on. So that's not the power, that's activating the outputs. Now, what I'm measuring today is with this pin, I'm measuring the electric potential relative to the ground. So voltage measurements always take two leads. You measure the voltage across a thing. So the voltage between the ground lead, which is connected to the negative terminal of the power supply, and this electrode here, the magnet on top, helps it stick to the board underneath. This electrode is connected to the positive terminal of the power supply. And it's placed on top of this silver bar. I've got two silver bars painted on my black semi-conducting paper, partially conducting paper. And those are now at 10 volts of potential difference or voltage. So if I place the pin at the same location as the ground, even better, I can touch it to the actual terminal. I'm going to read 0 volts on the voltmeter. If I place it across on the other conductor, I should be reading 10 volts on the multimeter. And you'll notice that as you scan to different places, you can measure the potential relative to the ground, relative to that 0 volt potential bar. Anywhere on there, you can measure potential as well. Now, the black paper is special. It weakly conducts electric current so that, with lots of resistance, so that between these two bars, with 10 volts of voltage, we get a gradation, a gradual decrease from the 10 volts down to the 0 volts. You'll see that when you measure it. We can place this pin anywhere on the black paper, including out beyond the ends, and we can measure the potential. So in the first part of the lab, you'll be scanning all over the board, looking for the potential at various places. The way to measure that, the way to record things, is to place a nice piece of tracing paper over that black paper. Now the point of the white paper is so that we can make marks on it. We can measure, we can draw right on there. And when you push the pin, just make sure you poke through the white paper and get into the black paper. For example, I could make a measurement right here and say that that is around 0.8 volts. So I could make a dot and hit 0.8. Another way to approach this is to take a look and see if I can scan for particular potentials. Like 1 volt, I could scan and locate a position with 1 volt of potential difference compared to the negative bar. I would make a mark there and label it 1 volt. Now if I make a whole bunch of marks that are labeled 1 volt, I can connect those up. That's an equipotential line. I create all my equipotential lines on this surface and get a map of this area, this space. The last thing that we're going to do is, instead of using the multimeter, let's use this wireless voltage probe connects to your computer's graphical analysis software. It's a Vernier sensor. And with this, we can measure the potential as a function of position. Now, usually when we were using graphical analysis, we would tend to use a time-based measurement where we're looking as a function of time, what is our sensor reading? Let's switch over to an event-based measurement. So with my pin, I can connect the pin to the voltmeter, the digital wireless voltmeter, and I can say, all right, graphical analysis, I'm recording an event right now. I'm going to hit collect. You can have it collect for 10 seconds and then enter the position. This might be 2 centimeters on the y-axis, for example. Record the position as the sensor's recording the time, the voltage data. So now I build up a graph of the voltage recorded, the potential recorded at any of these places along the y-axis. I'm going to go from the bottom of the board all the way through the plates, between the plates, and then beyond the plates up above. And I'll create a graph of potential as a function of location that I can then analyze. That's, in a nutshell, our week 3 lab activity. Good luck and enjoy.